alltså. Ja, hej. Ja. Ja, little babe show. So I wonder how this scheduling thing actually works. It says I have 3 concurrent viewers, so I can only assume it worked a lot better than just going randomly live, which you would expect maybe. It turns out scheduling works, guys. I have figured it out, I think. Let me just sort of figure out also the upload here. Hang on. There you go. Right. Now the latest video is up. Or it should be. Maybe. No, it says it's private still. What the? Public. Done. Save. Now it should be up. Yeah, there you go. Of course, I mean, don't watch it now. You're on the live stream now. Watch both. No. Anyway, let's see here. Let's see. We're doing some HTTP stuff. Some very, very basic web server stuff, maybe. I have a cat that's trying to nestle in my armpit. Anyway, let's see here. Also, I can't use my keyboard at the moment, but we'll get there. There you go. This is HTTP client. Let's just say HTTP server. How is everyone, by the way? I mean, I have no idea. I don't know how this even works. Concurrent viewer says 3, right? I don't know what that means. How are we doing today? Import core net, probably. That's what we want, right? Main is a proc, takes no argument, does something. Let's just say log here. We're gonna create a console logger. And for now, we're gonna debug if lal. Net declared but not used, sure. Let's see here. What we want, task file. Let's just autocomplete all of this, right? This is gonna be fine, I'm sure. Build HTTP server. Yep, sounds good. My dude. Let's go here, task HTTP server, like this. There you go. Beautiful. Can everyone see the text? Someone. Nice to catch the stream. Been slowly making through your catalog videos. Yeah, it's getting harder and harder, right? No, they're not that many, but I hope they're, you know, they're good. I hope you're learning stuff along the way, right? I would hate for it to be like you're just sort of going through them and, you know, don't feel like you're getting actual content, right? Because at the end of the day, I really want you to actually write the Odin programs, right? But yeah, of course, like you have to learn what you, in some ways, what you don't know yet, right? And so on. Good. Okay, text size is fine. This is a constant problem, right? I have learned there's no one size fits all when it comes to fonts and so on. It is definitely a thing that ends up being more a problem than anything else, to be honest. But yeah, the Odin videos, you know, I hope the learning videos are good, the kind of more focused ones, right? Because they are meant to be gone through, like, here's the stuff that you don't know yet, right? And the basics we need just to do stuff, right? Because at the very core of everything is just, we need a way to write procedures. We need a way to bundle some data together, basically, right? Of course, you could not do that, right? But these are the very basics of everything. Hello, Zdania. How are you doing? I'm gonna have to remove this tiny cat. You're not so tiny. Non è vero. Yeah. That's only now. Yeah, stuff is good. Stuff is good. I'm actually made an episode that I had kind of pushed forward a little bit. It was released just now. And of course I'm vampiring the potential viewers of that video from myself by streaming. But it is what it is. As long as you're spending your eyeballs here, right? That's the what we want, said the media person. That's the idea, at the very least, right? Yeah, it's about object-oriented programming, like I said on the Discord, right? Not in the sense of, you know, oh, a class keyword and stuff like this, but, you know, you can in fact do object-oriented programming in C if you want to, right? So that's the kind of object-oriented programming we're talking about, where it's more about the objects kind of themselves holding the code for doing things and stuff like this, right? And we have a few tools in Odin to do this in a mostly reasonable way and so on, a little bit of syntax sugar and so on. But it is a little bit more, let's say, Rambo, right? It's not necessarily with these, what do you call these? Training wheels, right? You don't really have the training wheels that sort of hold you in place a little bit, right? It's more like, no, we deal with knives here, right? We just sort of juggle knives, and that makes for a really cool thing, but it can be a little bit like, you know, you obviously have to do a little bit of bookkeeping and so on, right? You have to manage things yourselves, but what you get out of it is a lot of power still, right? And so yeah, I mean, that's the spirit of the video at the very least. What I hoped to convey. Usually when it comes to stuff like this, first of all, it's very hard to come up with examples, right? The examples are usually very convoluted, contrived rather. Like they're not real scenarios necessarily. I did try to come up with a, you know, something that could conceivably be real, right? And something that I have in fact done in other languages, you know, in certain ways. So yeah, Yes, let's make something, right? Something that vaguely approximates an HTTP server, right? So basically, first of all, let's take arguments, right? Core OS arguments, OS args. This is longer than the binding. Sure, this sounds reasonable. So for those who this might be new to some people, I have no idea what the level of, people, how, comfortable people are. If you're wondering ever why people are saying, usage something here, and then referring to the first argument in an argument list, this is because most operating systems, certainly Unix and, which means by extension Linux and so on, will basically have the actual binary name in the first argument. So whatever you called that program with, right, whatever the binary might be named, that is what's going to be inserted there, which means, for example, certain programs will actually run the same binary in different modes, or it will run different binaries that are basically linked to one binary, right? And this is basically what they call porcelain, right? So for example, if we search for the most common porcelain is basically, or the one people use, generally speaking, plumbing and porcelain here. Let's see. Porcelain is basically the outer shell, right? That sort of you type the commands and so on. Blah blah blah. Let's see here. Subcommands. Let's see here. It has a number of subcommands that do low-level work and were designed to be chained together Unix style or from scripts. These commands are generally referred to as git plumbing, while the more user-friendly commands are called porcelain, right? So what you can end up with is basically a git command that is effectively like a binary on top of git that calls git in a certain way or something like this, right? And then this warning or whatever it might be will actually be your binary name and so on, instead of just git something, right? But yeah, BusyBox is also a good example of this, where BusyBox is one binary that does multiple things. So it basically just goes into a certain mode in order to do other stuff, right? So it represents multiple commands and so on and so forth. And then you can use links to that binary to basically pretend that you have different programs, but you only have one. Anyway, so this is basically why I'm saying here OS args, right? In case someone didn't know, because this is just arcane stupidity, right? Where basically you just have to know that that's sort of the thing, right? Let's see here, args1. Here we actually want strconv, which is an awkward parse. Here we actually want, if we're being completely honest, U16. But we're going to parse this as U64 and then just say, oh, this is a U16 or whatever. Let's see here. Parse U64 may be prefixed. Interesting. Parse U64 of base. I think that's basically the one we want here. And this is, hang on, let's see here. Yeah, this is the one we actually want. Let's just call this one. With a base, we get two values out and so on, right? Port OK is what we can say here. We could also say OK if we wanted to, but that doesn't really matter. If port is not OK, we want to obviously exit like this. Context logger log. It invents these interesting ideas a lot. We don't have font. We are not using port, so that obviously, let's just say log debug if. Sure, sounds good. Here we are going to have to set up some stuff. Let's see here. The gray stuff is GitHub Copilot, yes. This is the only thing I use in terms of those. I have no idea what other things exist, to be honest. But yeah, I use this one, and I guess I use it a lot. Most of the time, though, I've found that you usually have to constrain yourself a little bit, right? You know, going like full blast with the tab completion is a bad idea, generally speaking, because of course, like you saw, it just invented entirely new syntax and so on. It doesn't actually have any knowledge. It's just sort of doing whatever, right? So here we want an endpoint. It's been a while since I did this, by the way. Opa. Here, address and port. Here I kind of want to say, hey, parse endpoint. Sure. Well, no, let's just do this. Endpoint, net endpoint, of course. Net endpoint. And we have, it said an address, right? Which is a net IPv4 address. Which one? IP4 address, this one. We're gonna say that one, and then we're gonna say port equals port. And I don't remember what that one is. Let's save and see what's up. U64 to int. So obviously it wants an int, right? What we can actually just do here is just say, hey, promise, super mega duper promise, it's an int, right? And of course U64 to int is, it's probably going to be safe, right? We could of course check that this is below, for example, because ports are actually U16s. They can't actually be U64s. You don't have that many ports to open even, right? So that doesn't work. Now we have to check here what this is. This is an array of U8, right? And here's actually an interesting thing. I'm not entirely sure if I have gone through this. I probably don't. I haven't. Distinct types, right, are effectively the type on the right, but we can't just pass any version of that. We have to actually pass the actual type, right? So if something wants an IP4 address, I can't just pass an array of 4 bytes, right? I actually have to say this is an IP4 address, or I have to use a function that produces an IP4 address, right? This is known as a new type in Haskell, and so on. And a new type is distinct in the type system, but at runtime it has no representation at all. It doesn't exist, right? And you might be wondering, well, hang on, do structs have this, right? So if I said, for example, IP much more address, much more than 4 address, and I did this, and then I just said, you know, oh, this is yeah, A, B, C, D, they are all bytes, for example, right? If I did this, you might wonder, well, you said these types don't have a representation in the type in the actual runtime, right? And this actually doesn't either, right? This is equivalent to an array, right? Actually, in fact, if I just said, hey, bytes is 4 bytes, this is exactly the same in terms of memory as well, right? So from that perspective, in these languages, these types of languages, is not necessarily, it doesn't make a difference, right? But if you were to use, for example, Haskell, right? This layer here, or a union constructor, for example, might itself contain a pointer to the data, right? So there, the distinction is much more, right? Here, we don't really have that much of a distinction, but we do want the type safety of saying you can't just pass any 4 bytes to me, right? You have to pass IP4 address, right? It has to be some function that produces it or something like this, right? Which is very natural, because if we have parse IP4 address, right, which is a proc that takes some bytes, right, like this, and then it produces a net IP4 address, right? For example, like this. This function could do all of the logic that's required. And this, of course, does return an IP4 address, for example. Of course, in reality, we probably would want like something that could return an error, for example, right? But that can do all of the validation. And then it says, hey, what I have is an IP4 address. And then we can use that together with this down here, right? So for example, we could conceivably find parse address, right? For example, like this, right? And of course, this should not be with a port, maybe, because if it produces an address, I don't think we want that. We might actually want parse endpoint. This one, right? 127 like this, and then we could actually say 80 here, right? And then we could say endpoint here. Endpoint parse okay, like this. And if this was not the case, bam, like this probably. And this is nonsense, of course. It's not gonna do anything. This boolean here didn't make any sense. We're gonna do this though, and let's say this, right? If I save now, yeah, we don't have any issue with the code down there, except that we are not using listen socket and so on, right? Let's see here, bind. Here you can also see, by the way, one of the things where the LSP is kind of seeing through a few of these things. So if we look at we go to listen TCP, right? We see that this returns a TCP socket, right? What is that? We find that it's a distinct socket. What is a socket? Well, it's a distinct I64, right? So basically, when the LSP sees this, it's like, it's just an I64, dude. I don't know what to tell you. But in fact, it is a TCP socket, right? So yeah, a TCP socket, of course, like if we go to these types, right, we'll see here that, of course, TCP socket, right, is different from UDP socket. Making these distinct means that you can't just pass a UDP socket where we're expecting a TCP socket, right? This is all in the name of type safety. It has no bearing on what happens at runtime, because a socket, like any file descriptor, is just a number, basically, in your file system or in your operating system, right? These numbers are handles in tables for those resources in the operating system, right? So when I pass, for example, 5 to the operating system, and I say, this is a handle, right? Then the operating system is like, okay, that process, socket number 5 is this one, right? So it's just, it's basically like a pointer, if you think about it, right? A pointer is really just a specific version of a handle into memory, right? And they all work basically the same. The handle pattern, if you will, is probably one of the most common in everything, right? So yeah, a socket is really just a number. That's why we're seeing here listen socket is I64. All right, let's see here. We want to bind some stuff. Hang on. We did not end up in the right place, no? Sure, dude. Let's see here. Oh, it's using reuse adder by default. Yeah, okay, hang on. Listen is, of course, doing all of this. This is what I was checking for, because I'm like, hang on, what does this do in this particular case? Here we can, of course, go to package Odin Lang. So this website, by the way, everyone should know this. It's just a very good place to go for just searching, like, okay, I want to know exactly what we're doing here. What do we have at our disposal, right? Let's see here. Let's see, bind. Not that everything has, you know, documentation, to be clear. I mean, a lot of it just doesn't, right? Yeah, okay. Let's see here. Sandbox. Nope. This one. There you go. Let's see here. What do we want to do? Sure. S, no. V, yes. This is an endpoint. This is a listen error. This is a network error, which, by the way, is basically everywhere when it comes to this. So if you go here, you'll see that this covers a lot. Network errors may be possibly a little bit too general, right? Because the truth is, we were doing a listen. Maybe we should only see listen errors, right? Not a big deal though. Let's see here if we, sure, this is not used. Here we want to accept, right? So here we actually want to, basically a while loop. We could have a done variable here, but as I explained in another video, I don't remember which one it was. When you have a done variable, and what I mean by this, right? Still running, right? True, for example, right? While we're still running, right? We want to do something, and then at some point you set this to false, right? Generally speaking, in most scenarios, you probably don't need this. And I would argue, start with this, and then sort of, you know, go into something else, right? Basically, because odds are you don't actually need this. You only need to break when you actually want to quit, right? So now we want to accept stuff, right? So here, client socket, sure. Accept error, net accept. And here we want to take our listen socket, right? We actually want to maybe pass other stuff. I'm not entirely sure. We also get an endpoint, client endpoint. We're probably not going to need this, to be clear. Yeah, this is it. If accept error is not nil, sure. In this case, it's done basically the correct thing. It basically said, maybe we don't need to, you know, exit. We just want to continue, right? We failed this, but it's fine, basically. And here we could just say net send TCP client socket. What is this? Let's just say welcome message here. This is a buffer. Yeah, let's say this, right? Welcome message is can I just do this? I kind of want to do this, right? So sure. Okay, I mean, we don't need more. I don't want to rush you or anything, you know. Basically this, but we basically need it to be like this though. These new lines are not going to work though, right? No. No, probably not. This is a raw string, but I don't think it will have the correct new lines because you actually want CRLF for these. What we can do is strings. It doesn't matter. I mean, obviously we're just throwing something together, to be honest. We want to concatenate some stuff, and concatenate, you can see here, takes an array, a slice of strings, and then an allocator to do it from. We're just going to allocate from whatever, really. And here we're going to say HTTP autocomplete 200. Okay, sure. Like this. And sure. This looks vaguely fine, right? We're going to verify. Welcome message declared but not used. Sure. And we want a slice of bytes from this. Hang on. Is that even... Let's see here. Is this doable? No. No, we have to say basically that this will be okay. Bytes. We're gonna use this one instead. Now this might be a bit of a stretch though. Can I convert untyped value of blah? Sure. Okay, that's annoying actually. Let's see here. Strings to something. This is always a little bit annoying. I don't remember what the byte. Bytes clone. No, that's not the one. Welcome. I'm just gonna try this at this point. No. Oh. Save me from this. Strings. Bytes. Okay. Alternative to this, bytes. B is a bytes builder buffer rather. B bytes init buffer init. And then no, we want init allocator. Sure. Len and cap 0. The cap will be sure 1024 sounds 2048 doesn't matter. Here we're now initializing this buffer, right? And what you can do now is you can just say bytes write buffer write like this, or you can do write string, for example, right, like this. You can then say buffer write string and then buffer write string, and this content length 12 can fuck off, but the rest of it sure, right, like this. And then you can basically say, okay, now we have this in this buffer, right? And then we can say welcome message is equal to bytes. Let's see if I can get the buffer to bytes, this one, right? This is now our welcome message slice, right? And now we will send this here. And it's already a slice, we don't need to slice like this at all. Send TCP will give us how many bytes we've written, right? And here we could basically say 4 bytes sent less than len welcome message, right? We could do this basically. Here we could say n send error is this, right? And bytes sent plus equals n. And here we're going to say byte sent is 0. We're going to start out with this, right? Send error is a network error here. If send error is not nil, sure, maybe. We'll see what that actually ends up being. Are there any questions, by the way, while I'm doing this? Failed to listen on endpoint, blah, 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 broadcast disabled. Okay. Broadcast disabled. Oh, hang on. I don't know if we could listen on anything, basically. Ah, there you go. Okay. This was, of course, because I did not have admin rights or whatever, right, to listen on port 80, because any port under, I don't remember what the port number is, but lower ports you will not be able to listen to, of course, like if you're just sort of trying, right? So we have to be basically admin, right? We have to use sudo for this. Let's see here if we can. Opa, that's not at all what I wanted, but fair enough. We don't need 80, of course. Here we're not closing the connection. That could be a problem. Let's see. Let's use this here. Net close client socket. This of course cannot return any errors, because how can you error out on closing something? That would be weird. And now you can see here that we have in fact connected, right? Now, this is one of those moments where if anyone knows the meme, draw the rest of the fucking owl, right? This is now like, we have drawn 2 circles, right? A big circle, oh, 3 circles, big circle, maybe a circle for an eye, another circle for an eye, and then step 4, draw the rest of the fucking owl, right? Because basically, of course, at this point is where we now take this and just say, move, you know, all of the actual logic for building all of this, right, needs to be generalized. It needs to be, oh, respect the headers that come in and so on. Because of course we have completely hard coded, like, first of all, it's just 200 OK, right? It's just content type text HTML. It's literally the same body all the time, right? And just this section alone, right, building the actual response, is of course a massive undertaking, right? And in some sense, I mean, it depends on what you compare it to, but of course you can spend a whole lot of time here, right? So we're not going to spend all that time, of course, today. We're not going to get that done, but I think here is a good place to sort of just sit for a little bit and maybe address if anyone has any questions. Probably, I would think. How long have we been going? Probably 5 years. It's always something like this, you know. We have been going for 41 minutes, actually. Not as bad, you know. But I suppose no one has any questions. Let me get some water. I'll be right back. Actually, how fast does this respond? The load took 45 milliseconds. I guess the entire thing, 92 milliseconds. That's just a long time, to be honest. Doesn't that seem super long to anyone else? 92 milliseconds. Are you kidding me? What's that even mean? Right? Am I crazy? Is that just my browser being, you know, slow, or what's that even mean? Let's try here. Yeah, I mean, it does seem slow, right? I don't know that it depends on the actual web server, of course, right? Especially the variance here, right? 134 milliseconds now, 85. DOM content loaded, 31 milliseconds. Keep in mind, we're only rendering just like a, not even a div. It's just HTML body, H1, right? How does a browser take 31 milliseconds to draw that? I don't know what that even, you know, why. And here, of course, it says like, you know, 0 ms for the timings. And to be honest, this fav icon doesn't work, of course, because we're sending basically this HTML when it requests the fav icon here, right? So, you know, that doesn't make any sense either, basically. But yeah, all of these timings say basically 0. And I'll be honest, I've never checked these for anything else, right? So let's say we check this for, you know, the Odin overview, right? Of course, most websites have just a shit ton of stuff that happens when you do stuff, right? Timings. Okay, obviously we're seeing a lot more. DNS resolution, of course, I'm not seeing on 127 because this is the loopback in, you know, interface. The loopback interface is basically just saying we're already home, right? Like we're already at the destination because I'm literally calling myself, right? Connecting 6ms, TLS setup, of course, yeah, this is HTTPS. Sending, waiting, 133 ms. Receiving, 6 ms. Man, this web stuff. I mean, yeah, I don't know. And this is not even including layout and stuff, right? You know, DOM content loaded, 505 ms. Half a second, right? That's crazy. This is crazy, to be honest. If I'm not gonna do a cat, I'm gonna keep the cache when I do this load here. Okay, better, right? 152 milliseconds. Still though, yeah, browsers. They're not my favorite thing in the world, I have to say. What browser does everyone use? I use Firefox, as you can see. Or maybe, is it even possible to see? Yeah, I mean, vaguely. You can see the look of it. It looks kind of like Firefox, I guess. But yeah. What's everyone use? I mean, statistically speaking, you're all using Chrome, for which I hate you. No, but yeah. I haven't used Chrome. I mean, I use Chrome for like all alternate websites and so on, right? So I'll have Chrome for, you know, if this particular website, you know, blah, blah, blah. If this doesn't work with Firefox, I'll use Chrome, for example. Or there's an extension that I use called Speechify that basically text-to-speeches articles, if you want, for you. And I use this sometimes to walk around while I'm listening to blog posts and stuff. Because I have these Bluetooth headphones, right? Yeah, Firefox is a little bit of a mixed bag, right? Because the thing is, there's nothing outwardly bad about it, right? It's just not Chrome. That's the problem, right? And you have these developers that basically are like, well, I don't want to support Firefox. What, like 6% of the world uses this shit? Why should I care, right? You have even people like Theo who are basically like, well, we don't test on Firefox. Yeah, okay. I mean, it's a completely legit browser, but because it's so unpopular, right? It's just not at all something that people care about, right? And so sites are bad in it, so people don't use it or whatever, right? Now, granted, it's been a while since I had a site that was just like, wow, this doesn't work in Firefox. I mean, I guess that only really happens to Theo products or whatever, and I don't use those, so it's fine. But it is a little bit like, that whole thing is just a little bit stupid, right? The whole cycle of, oh, we don't support this because no one uses it. Well, no one uses it because your stupid garbage doesn't support it, right? I mean, there was a time when basically people were like, well, you need Internet Explorer to use this internal system, and so on. And if people think like this, of course, yeah, we can't have nice things at all, right? Imagine this: an operating system is like, well, you can't program in Odin on our operating system because no one uses it. Well, get a proper fucking operating system then, right? Like, what's wrong with you? Like, what kind of thinking is this? I should be able to use whatever the fuck I want. It's just, you know, basically it's just native code at the end of the day. You know, just don't architect things so that they just break when someone uses something that they like, right? Makes no sense, to be honest. Anyway. Yeah. I don't know why I started talking about that. But yeah, browsers, like Firefox is a mixed bag sometimes. I'll be honest though, Chrome is not better at these things, like the whole performance thing and so on. In my experience, it has not made much of a difference. They all eat somehow. You open one website and suddenly there's like 3 gigs of RAM is being used and you're like, wow, okay. I guess JavaScript, you know. Actually, how much is Firefox using right now? Let's see. I have to just check so I don't have anything weird in my list of processes, you know? Firefox, what are you doing? 1.5 gigs-ish. And not so bad, actually, to be honest. But, yeah. So what do we want to do now? We want to parse some headers, presumably, maybe. Right. Let's receive some content. Like this, of course. So we have a receive buffer. And here we want to accept the connection. We want to bytes read. This is probably, I don't know that we need to do that. We'll see. Net receive TCP like this, client socket. And here we actually want to say receive buffer like this. Is there a size here? I'm not entirely sure. No, we don't need that. Because of course the slice contains the size. So this doesn't make much sense. Let's see here. Here we do want bytes read or received is 0, and then we actually want to say bytes received while so hang on, bear with me here. Bytes received 0. Not really. Let's say 255. And when you start making up bullshit values, you should consider maybe you're not doing the correct thing. But we're gonna do this for now. 4 bytes received is not 0. N this. Generally, if you receive and you're receiving 0 bytes, that means the other side has closed their connection. Here though, we may or may not have interesting errors. We're gonna see. We're gonna just have to see. Sure. No. Let's print some stuff. Why am I not printing anything? Guys. Sure, we're gonna do log debug if received this, and then sure, like this. Sounds good. Bytes sent. No, hang on, I'm in the wrong place. Received. Like this. Unable to connect. Oh, HTTPS. Why have you done this to me, Firefox? We don't have security here. We don't do that here. Stop it. Here's what we're receiving. And we are receiving, and of course, our connection is being, you can see here, connection keep alive, right? What this means is that the browser is basically saying, hey, I'm going to keep this connection alive so we can basically reuse it, right? And that means, of course, we're not receiving 0 at any point, really, right? So we have ended up here now, basically in a mode where we don't want to be. So here what we can do is, let's see, we could just sort of use the fact that you can see this content here, right? This double enter here basically means that, or here maybe rather, means that we are done with that request, right? We have received here, or has double new lines. And has double new lines will be, we can actually define this in line. Like this, has double new lines will be some, we have some data. And this is just a slice of bytes, bool, like this. And yeah, hang on. Should I only check the end or should I do a for through the whole thing? Let's check the end and see what happens, right? Because I don't want to really... Yeah, this should be fine. I'm trying to think of, you know, will this be an issue? Compare, here we have the left hand side and the right hand side, and what we actually want is data, len data minus, sure, this would kind of make sense ish. I don't think that this part will actually make sense here, but what we can do about this, to be honest, is effectively here replace these, right? This of course should be this, and like this, has double new line, double new lines. Let's say it like this. And if you're wondering, by the way, this here does not mean that this is somehow some cool nested function that has access to a bunch of stuff. Like for example, if I refer to accept error here, right? This does not work. Because this is not a closure. It doesn't close over anything. It doesn't capture any state outside. It doesn't do anything interesting like this, right? It's just a function we can define wherever we want in the end. The reason I'm defining it here is because we're next to the problem. So it's sort of just convenient to do that. Let's see here. This didn't do shit. Because we're somehow again on HTTPS, because of course we can't have what we want nowadays. Let's see here if I can. Let's print this value, right? Last 4. Log debug if. Last 4 is a string. And here I usually put quotes around it because it's much easier to see. How do I just get it to sort of just be on HTTP, dude? I don't know how to even tell you this. Is anyone seeing this output that I'm supposed to be seeing? Am I not logging this? Of course, we are not. Hang on. I mean, we could put this logic down there, though, to be fair. Let's do this, right? I just want to kind of see this code being executed right now. Sure. Okay. There you go. Here you can see last 4 is printing these new lines, right? basically. This is why you also need the quotes, right? Because what if it didn't have the quotes here? And obviously I'm saying this from experience. Put quotes around your strings when you print them, because you will have white space, and that white space will not be obvious. I can tell you I have caught weird tabs being present and stuff in all kinds of content, right? And so on. So it's just a tip for those who might want to save a couple of minutes, you know, every once in a while. This also applies here, right? Basically. Sometimes if I know that I'm going to have big strings also, I will basically say, you know, like this. Something like this, right? Where I'm actually even making it more obvious, right? So let's look at what that output actually gives us. We can see exactly where this string is supposedly starting and stuff like this, right? Then we get some semblance of order and so on. So what do we want to do here? We want to add something, like something small, something reasonable. And of course, by the way, you can see we get 2 requests here, right? Is there a way to print the hex ASCII values of the string instead? Absolutely, let's go. Let's fucking go. X. And now we're gonna see. Bam! Not super readable sometimes though. But this is obviously very useful, for example, when you just have numbers, right? And you can also make it a slight bit nicer. So for example, we could see, we could say here, hash X, for example. This should give us basically, and of course, this is, just to be clear, this is a slice of bytes, right? So now you can see we get 0x and so on. And it will actually, when you add the hash to your prints, you get pretty printing as well. That's why we get all of these new lines. This is very useful for structures and stuff. So if you have a struct, you can just print it with your X. So if we said, for example, hey, I'm gonna skip this here, right? This is now gonna be S again. And instead, we're gonna do probably what you were thinking here, the last 4 here, right? We can say these, bam. And now we can run again. And now we can actually see these values, right? Even more importantly, we can also say, you know, I really am only mostly concerned with one of these, for example. So we could say, for example, last for 0, maybe last for, let's say all of them, right? Here we could actually say, %x, for example, like this, right? And now we actually get down to a little bit, you know, the more, let's see. And there you go. And here you can see now it says dada here, right? And that's not the nicest thing, but what we can do is here we can actually say 0 to x, for example, right? And we can do this in all of these places. Hang on, there you go. Like this. And now you can see that we get 0D, 0A, 0D, 0A, and so on, right? Of course, data is nice, but this is maybe, you know, a little bit nicer even. Then of course you can also do the hash. I'll be honest, not remembering where you put this one. Let's see. I have now put it before the X. Just before the X, right? That gave some garbage. So we're gonna try putting it before here, right? Yeah, and now you get 0x0d and so on, right? So you have a few options here, right? And if you're printing on a value level, You get a lot more control over sort of the small specifics, right? Because when you're printing the arrays, what you're controlling the printing of is the array in a way, right? So you don't have as much nice control over that necessarily. It's more like, yeah, those things I'm usually just doing in the moment because I'm trying to print a struct that I really am interested in what it's looking like, right? And so on. And that's mostly how I use, for example, the hash, right? And the way this shapes up is basically like this, right? So let's say I have a struct. My thing is a struct. Actually, let's just say user. Name is a string. Age is a U64. Well, we don't need that much. A byte should suffice. That's so sad. Anyway, if we have this, right, and we wanted to actually print this, right, we could actually say user. We could say here user. It's a user like this, right? This suffices. This is initialization, right? And then we could say log debug if. And this takes any format string, right? %v will just print this user, right? Like this. And so here, user is now printed, right? Complete with everything, right? If I now wanted this nicer, this is usually what I'll do. And of course, this kind of hinges on, you can't have massive structs with slices in them and stuff like this. In that case, you're gonna have to probably just sort of print individual parts, right? Which I do actually in certain projects. And now you can see that this is pretty printed, right? So this can be a very useful sort of like on the surface debugging tool if you need it. Does that make sense? I mean, I'm guessing it does, obviously. You had the idea because you figured, yeah, this will make sense, etc., etc. But yeah, I'm just trying to kind of, because obviously like this is a general facility, it applies to a bunch of stuff, right? So slices, dynamic arrays, maps, and so on. And you can use it with all of those, but all of the collection types, the composite types, are a little bit awkward sometimes with these, right? It is sometimes very useful to say like, well, I know I'm really only looking for these particular things inside or something. Or in the case of maps, it can be very useful to just say for kv in map in M, right? And then print the keys and the stuff, right? Basically. So that can be very useful in these cases. Hello. I am sorry, I don't know how to say this name. Eliseu. Lucena Barros. Barros. That sounds vaguely Spanish though. I'm not entirely sure. You're possibly not Spanish. In that case, that was probably very offensive. And for that, I apologize. Hello, UI. But yeah, so that's how you can print stuff in a kind of reasonable way. I use %v a lot. Like it's very convenient. It just figures out based on what you're trying to print, obviously. My most common ones are probably %s, %d, and so on. Ah, the name is Jewish. Okay. Okay. Yeah. Okay. So you're Brazilian. The name is Jewish. Neither of those are super close to Spanish. You could argue, but it's such a Spanish sounding last name though. Barros, rrr. I'm probably the only one. I'm probably the only one who thinks so. But anyway, it's a good last name though, strong. Now I made it sound like there are bad last names and they're weak, but it's not necessarily what I mean. But hang on. I can't see some. Okay. Does anyone know how to remove the emoji reaction thingy from the live chat? Because I can't see your text. Like the last word on the first row is always unreadable to me. So can someone help an old man try to fix this problem. I could use the pop-out chat. Yeah, thank you. Thank you for adding a new line. No, I've used the pop-out chat now. So now I'm gonna have just an entire thing, massive chat instead. Let me put that on the right screen. Yeah, I don't know what they were thinking with this. Hang on, I can show you how it looks. It's, can someone type something? So you see this section here, right? If I type something here, and it's a little bit longer. Hello, Skitrias. From the Odin Discord, by the way. It will be occluded by this thing. Right? So you see here on my screen, occluded is just like, yeah, if this was a short word and it was positioned there, we wouldn't see this. It's just frustrating. Like, this is kind of basic user interface stuff, I feel like. You can turn it off, I'm assuming is what you're saying, in customization for the stream. Ah, live reactions. But what if I want... Oh. Hang on. Ah. But now no one can react. And we all know React is the most important thing in the software landscape. It's the most important project in software in the last 10 years, according to some people. So if we don't have React, how are we going to do anything? No, I'm going to leave that there. I do like the feature, you know, because suddenly someone can be like, hey, oh. Anyway. So yeah, we're now checking for these new lines. We're handling the keep alive, right, from the client. Oh, hang on, I'm printing a bunch of shit now. Let's not do that. Ah, received is fine, actually. Never mind. I thought we were printing something weird. I probably at some point should actually move to bed, but you know, we're here, we're alive, we're writing some Odin code. Life is amazing. So yeah, so we're handling 2 of these requests right now, right? We have the fav icon. We could, I'm debating now, like, is it worth trying to add the routing here, right? Because, okay, let me go through what that would mean, right? If we add this routing, basically, I would want to say, basically, in the received data here, basically after this line here, we would basically check, like, okay, parse the actual HTTP request, right? Create a request from it, right? That would basically be the thing, right? Currently what we have is header parsing, right? So if we can see here that we have this is now in HTTP client. It's not really accurate. The parser actually parses headers. And of course, those apply also to the server, right? The server is getting them and so on. So we would basically parse I forget what this is called, the subject line, whatever it might be, right? Basically the method, the protocol, the path, and the method, I guess. Here, this rather. So method, path, protocol, right? And parse all of the headers, right? And then essentially do stuff based on those things, right? Of course, we can choose to ignore most of it. It's not really an issue, right? Oh, this is interesting, by the way. I'm leaking a cookie from a project I was working on. Of course, because we're on localhost, right? Luckily, this is not a problem. Luckily, this is not a problem. I don't know. Maybe it is, maybe it isn't. We'll see. No, it's not. This project is basically dead. It's fine. So we would basically parse this, right? We have this part. We would just sort of slice away for after we read this line, we would slice away here, right? Which is not really an issue, maybe. Maybe we can actually add this, right? Parse. I have the HTTP RFC somewhere in a dark box somewhere. RFC. I mean, it should be, let's say it's this one, right? Sure. I'm not concerned with your new versions. It's fine. We only really want the terminology here. Yeah. Don't fucking bother me with this shit. General header, request header, response header, sure. I'm confused why I'm not getting it here. Let's see if we can just sort of get this from somewhere else. Just give me an overview of what a message is, or like the actual request. If I search for path, maybe, right? Path. History and evolution. God damn. Line. It has to be called something line, no? It's just one line of the thing. Surely. Let's say method. Messages. Request target, possibly. What is a request target? Determine a target resource. Sure, resource is what we would call the second line, second bit, right? But then how? Okay, let's just say message. I'm done. I'm done. Let's say the data is here. I don't really want to use a string. I mean, it was a mistake to use a string for this one, to be honest. We're not going to do that now. We're just going to do this now. I'm going to have to fix this later. Sure. Not super concerned here. This will basically return, let's say message line. No, message. I don't like that at all, actually. But message, possibly an error. Parse message error, let's say, like this. And here what we could do is basically, now we can essentially just use the tokenizer stuff here to deal with this. The tokenizer is based on a string, is it not? That's garbage. I'm just gonna make this string. Do I though? Am I? Bytes clone. Byten, bytes. Byten sounds vaguely German somehow. Clone, no. Strings, maybe clone. Clone from BTS. Clone from bytes data. Allocator. Let's just do that. None of this is final. It's fine. It's fine. Data string. Let's call it that. Alloc error. Fuck off. Let's just do this. And here we're gonna say parse message error is a union. Union between a mem allocator error and fucking nothing so far. Actually, no. Hang on. Expect error. Expected token error, expected one of error. Probably some of these. Something. Expected one of will probably be relevant because we are going to expect certain methods and so on. Let's see. So, tokenizer create with the data string. This gives us the tokenizer. And here we have tokenizer expect exact we could do, and then expect basically an upper symbol with get inside of it, but we're not going to do that. Expect one of is what I would want here. Why am I not seeing that? No, expect we can do at least tokenizer, and here we could do an upper symbol, upper alpha, fuck off, symbol, like this basically. I haven't used this in a while, so you know, forgive me if I'm doing this wrong. And here we would basically get a T, and because we've said, let's say this, right? Maybe expected token. Hang on. It's not what I want. Tokenizer. This may be one of those things that I've redesigned somewhere else and now I'm just confused. This is not at all uncommon when it comes to this code. I have copied this particular code to different projects several times. Expected one of, expected this, sure, actual, yeah. Where do we return expected one of? This is the function we want, very likely. Never, nowhere. Let's see. Unthread. Let's see. In unthread we actually have a parser and a tokenizer, etc. The parser right, expected one of error. This is also not returned anywhere. What is happening? This returns maybe expected token. Yeah, hang on. Let's just do this. I'm tired of looking at this now. We're gonna just sort of plow through, so to speak. We are going to say that this can also be a maybe expectation error. Actually, what is this exactly? It's a union of this and this and this and this. Yeah, hang on. I am fairly certain. Let's just do this, right? We are going to just say we're going to say here RG this. Is that the wrong order? Probably is, right? Ah, no. The first one was correct. So I'm using this in a few different places. We have toil, which is a toy language, hence the name. We have the HTTP client, and then we have the unthread project. Unthread project was what we looked at before. I'm gonna just briefly check there again, because I feel like there's something missing from my current knowledge of this code, and we don't want that. So Tokenizer expect. So if we go to the parser, does this? So here, for example, we're using Tokenizer expect or return, right? So this is what we want. And this returns a parsing error, which has these, right? So maybe this is basically what I'm doing again. I don't necessarily like that so much, but we're gonna do that. It's not really a problem, to be honest. Let's put this, where do we do this stuff? Parser. Like this. Undeclared name mem? Are you kidding me? What kind of file are you? Don't even use mem? Parse message. What am I doing here? Oh, right. Of course, I created the message thing. This is a struct. We have a method, which is, I mean, let's say it's a string for now. I don't like that at all. Fuck it. Unidon. Sure. Get. Post. Put. Sure. Delete. I mean, I don't want to define all of these. Let's go with the two ones that people care about. And here we actually just want effectively this, right? We can effectively just make these like this. Post, of course, has content inside of it, right? So here we would say data, which is some kind of slice of bytes or whatever. It might be. Whereas a GET request really isn't doing much in terms of the actual method, right? We still might have a path, right? So we could choose here to say, you know, all of these have a path, for example, right? So we could say this, you know, resource or whatever it might be. Am I against this? Not necessarily. I mean, this would effectively imply that we're basically parsing this when we're parsing this line, right? And it's the actual method or message that has these things. So let's just do this for now. It doesn't really matter. You can always rethink some of these things, you know. We have a method. We have some kind of path. This is not what they call it, I'm sure, right? But we're gonna do that. And we also have some subheaders. We could have a protocol here as well, right? Effectively. And I'm going to kind of just be a little bit awkward here and say that this is a string. The path I'm also going to make a string actually, because the tokenizer deals with strings anyway, so it's fine. And now we're gonna parse this tokenizer upper symbol here, right? And here we can actually just return im and error or nil down here. Now we have t declared but not used, and when we get this here, right, we have this t. Here we want to check that this is one of get or post or whatever, right? So we could say if t token like this basically, because we get a source token out of this. We don't actually get an upper symbol. What this line does is effectively just verify that it is in fact an upper symbol that we have, right? Other than that, it's not doing more, right? So it's just good old casting or whatever down here, right? And of course, a T is a source token, which itself has a token in it because the source token has location information. So not super important, like, but this is basically just what we have, right? And the upper symbol has a value, which is a string. And of course, you have a lower symbol that starts with a lowercase letter, right? So this should be get, right? We want to parse basically this entire, specific format. If it's not get, we want to actually return. This shouldn't work. Expected should be a token, and here we actually want upper symbol. Sure, there's an implicit value equals here. Fuck it, we're gonna go with this, right? And of course, yeah, actually, hang on. Cannot convert untype to message. Yeah, we need just message like this. It's fine. Expected type for the argument T. Maybe we don't need maybe here. Cannot assign value expected token expected double symbol blah. Type expected token to parse message error. Expected token. That is not an error that we have. No, hang on. No, we do want this, right? Hang on, I'm fairly certain that this should be maybe the case at least. Fuck, I'm so tired of this message. This here, parser. Let's say expected token here. We're never using this. Sure. Okay, we're turning it into effectively some other. That's actually better in the long run, of course. Right. So if we see here, if we look at some returns, we'll probably find here that, we are in fact constructing other errors in certain cases. Most of it is or return, as you can see. Man, it is only or return. I don't see a single case where I'm actually returning another error. Do I? This is yeah, no. Let's go to the Tokenizer and let's see what we actually are doing there. Yeah, I mean, this is just sort of doing this, right? Hang on. Am I? Let's relocate this to 9. I don't know if you noticed, but I was running out of numbers down there. Let's see here. Expected token, sure. Should this not work though? No, I'm just confused. A little bit tired maybe. Of type expected token to parse message error in return statement. Parse message error is in fact this. Shared nil, could that be it? No, it's not it. Parse message error. Oh, no, hang on. Expected, actual, location. I mean, location, we don't need to fill that in. It's just not going to exist. It's fine, mostly. We could actually even do T location for this one, right? Because it'll work fine. parse message error in return statement. I don't know what I'm missing. It is odd, to be honest. Let's look at this properly. Let's get the basics out of the way of just like, okay, an empty one, right? This is not the issue. Because otherwise you may have some other issue, right? Oh, hang on, what? Okay. Cannot assign value expected token, sure, of type expected token to parse message error in assignment. Why is that? Maybe expected. We don't love this. Yeah, this is why, I mean, this is why I shouldn't have these maybes. It's just awkward, right? I should have one expectation error that can be basically thrown from all of them, or not thrown, that can be returned from all of them, and then basically I don't have to do this at all. I just have a nil, there are no maybes, and so on. The mistake that I made, let's look at the API just to see the mistake that I made, that I think is key to this whole thing, is in the tokenizer, right? Let's see here. In the tokenizer, when I call expect exact, right? The mistake that I have made here is to try to return a specific expectation error, when I think this should just be expectation error, right? And expectation error is this, right? That way we just do this instead, right? Let's try this. I might just be buying, even more problems now, but we're gonna try. Expected error is an expected token, and that is a valid expectation error. Thank you very much. But regardless, of course, here we are not saying that, so we can do this now. Mismatch type may be tokenizer expect is still returning this. Expectation error and expectation error. This might be because, hang on. So this part is fine, right? But this is not, because we can't actually compare these things now, because they are expectation errors, which has this string inside of it. Now these strings can be compared. That one is fine. What can't be compared is this expected end marker instead, right? And so what we could do with this particular error here is basically cast it, right? So here we actually should have an expectation error now, or no, hang on, like this. We could say E is expectation error, expected token error, like this, right? And that means this one is what we're comparing, like this. Undeclared name. What did I do here? Ah, this. Expected token. This one. Now this part will work. And here, what we can do is this same thing. We can say E is expectation error, right? With expected token, like this. And then we can compare E to this. In tests, this is actually fine. So just to be clear, we've had this in some of the videos, of course, but when you do this dot and parenthesis here, what you're actually doing is basically casting some union type, right? This expectation error here is an expectation error of some kind, right? And we're basically casting that to another type, right? If you want to do this safely, you can basically say is expected token, right? This value here now will be a bool that represents whether this actually made sense, right? Could we cast to that value, right? And that's the way to do it safely. In tests, you can get by with doing this, especially if you're doing just a small refactor right now and you're really just tired. Expectation error, like this, maybe. Okay, we have no more maybes in this file now. In the parser, we are not dealing with this here. So what we can do now is we can say parse message blah is now just expectation error, like this. And possibly we can just get by with it, with just blah. Like this. Expected an operand. Hang on, what are we doing? In the file, what is happening? What am I even looking at? I had a cast somewhere here. Error is equal to expected token, sure. And this we really want like this. To type expected token parse message there in assignment. What? Why? What am I missing here? Hang on. Now I'm kind of back to the same thing. Expectation error can be expected token. Do I have several expected tokens? Maybe. No. Expectation error is a union over these, sure. That's all fine. parse message error is this. I am having some kind of brain fart at the moment. Expected blah 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 of type expected token to parse message error in assignment. Parse message error is a union over two types. Surely if I said, for example, sure, this will not work, but we basically can just do this for now. So if we return an expectation error, we'll be fine. Something is not making sense here. Parse message error. Yeah, we'll go with this. So parse message blah blah blah. We have this. We have get. We're only gonna accept get for now. That's fine. We want to return a message, which is basically method, path, protocol, headers. And so here we want to say path is actually tokenizer read string until, and here we want until a space. Let's say that. And so path here should be just a string, right? Yeah, this is all fine. And we could actually conceivably just do m.path here is equal to, right? And then m method is equal to, sure, we're only allowing get at the moment anyway, right? So we could just do this. M dot protocol could be this, right? We're reading until the end of that stuff, basically. And then we could say m dot headers would be parse headers. Tokenizer. I suppose source with the current position forward, basically. I guess this could work. Header parsing error is also something we want. Right, and now we have this parse message. We are going to go to our blah blah blah, 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 blah server. Right, so we've received some stuff. At this point we should have received everything, right? And what we can do here is we can just say parse. Hang on, I just realized. Ah, yeah, we did put the headers in this. Right, okay. Message, right? Parse message. Yeah, this is fine. Parser, HTTP client. Ah, this is in the client at the moment. We of course don't have that. Let's just say this, right? And then just say like import like this, basically. Parse the message that we have. Undeclared name HTTP client. What was that called then? Hang on. No, HTTP client. I beg to differ. Is it the dash? No, even if it was that, we would have the, we could just do this, right? Client, basically like this, right? And then we could say HTTP client and just say this, but it's not that. Oh, it is that. Okay, never mind. Data, sure. We need this receive buffer with bytes received, and we take an allocator as a second argument. We're not going to care about that right now. And then message parsing error if message parsing error is nil, blah blah blah, log, sure. Otherwise we can start making decisions based on the message, right? If message path, right, is equal to /favicon, well, we can't just break. Can you just ignore this? What's the standard response for not having a favicon? I mean, clearly in that case you want to send something else, right? Net send TCP client socket 404 not found, sure, sounds great. And here we want to break. And what we could do here is in fact defer a net close, right? Yeah, this is not gonna work. Not found. I really want to do this, but it's not gonna work. Here we could do strings, bytes. We're doing this bytes builder again. Yeah, I think we are. Bytes buffer rather. Then we break after the favicon, sure. Let's try this. We've probably made some kind of mistake regardless. How long have I been? 155, okay. Let's see here, 127. I'm getting 200 for favicon, that's bullshit. This is not what we should get. So, I have a suspicion we are parsing an empty path. The reason for this is because when we parse this stuff, right, parse message, right, we are not skipping after the get, right? You can see here we're expecting this upper symbol, and then we should actually do tokenizer skip, skip any of, and then space and tab, for example, right? Like this. tab shouldn't be a thing. I'm fairly certain, to be honest, right? So we can actually kind of ignore that. Okay, let's print some stuff about our message. Okay, panic F. In the tokenizer, unexpected character slash. Okay. Okay, we can fix this. Hang on. Now this should be how you add this. What am I missing here? Is anyone actually watching? I somehow doubt it. Anyway, right, if we read a slash, this is the character that it's actually, because if we go to this code, we'll find that it's actually executing this, right? And it tries to basically print a snippet of what's surrounding it, right? And so the snippet here is basically, we read this slash, basically. But this should be fixed by this code. So I'm actually a little bit confused because it shouldn't be an issue when you have added this slash here. Right, we're reading this character, but somehow we're ending up down here. So maybe I'm wrong. Maybe I'm not seeing that character. Am I? Because here, right? We definitely should hit this one. I mean, I think. Let's see, right? I'm gonna prep a thing here. Debug HTTP server. CMDs. GDB. CLI args, I don't know that we can actually even give here, right? This shit is always so stupid in GDB. I feel like let's do this. Deps build, and we're not gonna say speed. We're gonna say none and debug. Method none, sure. Silent true. Oh. Right. Because we ran with sudo before, it wrote everything with root permissions, of course. Here we can set arguments somehow. Help arguments. Help. Arg. Man, I don't remember this shit. EDB set arguments. Set args. Set args 80. 80. And here we want to break somewhere, presumably. Tokenizer.Odin. Right. Let's say Tokenizer.Odin. Probably up here. 344. Let's try that, right? Break Tokenizer.Odin 344. Run. Yes. Failed to listen. Oh, hang on, port 80. We're not using the port that we're using in the argument. Hang on. Right. That should be fine. Right, so now we connect on 8080. This crashes, or rather it goes into a breakpoint right now. We throw up the interface. We switch. So now in Tokenizer copy, right, we have this position, right? Oh, right. Yeah, this is now going through a bunch. Oh, what? Hang on. What are we parsing now? Okay, I guess I'm confused about what we're even parsing from the beginning. Because our tokenizer position is 0. And if we look at that character, it's not really what I would expect. P tokenizer copy source. Tokenizer. Of course. our position is 0, right? We should be getting G at the start of this. I don't know that this makes a lot of sense to me. What the fuck is this? Adminer? What is this doing? Some kind of cached content. What on earth? So we have our tokenizer here, right? We have our position. Clearly now we should be reading the G, but somehow we're not, right? We are actually going down here. This is it's kind of confusing. Unexpected carriage return without new line. Where? Where is that? And then T. Yeah, now we read the upper symbol, right? I'm fine with that. Uh-huh. So here, by the way, you can see that this is actually V21 here, is our upper symbol. You can't see this here because, of course, this is just the C code or whatever that runs, right? But you can also see here that it took these 3 characters, like a length of 3, right? And then it basically did this, right? And then if we do next now, now we're in this code here, we're gonna go into skip any of, and this is really where stuff goes bad, I suppose, right? We peek at the token. Which goes into this code that actually gets tokens, right? We get a space here, right? Because that's actually what's happening in the data. Return that space. And here we get next token, and this is actually where the stuff is going to go bad, presumably. This is maybe not what I expected though. What? What is happening? What did I just step through? Current, right? We're going in here, and now the current character that we have here, right, is Tokenizer copy dot source dot data indexed by Tokenizer copy position, which is a space. Yeah, we're skipping this. Okay, hang on, next. Continue for match, right? We now peek at this token again, right? This goes through the code for seeing, you know, what do we have, and again, it's this, right? Now we're on the slash, but here is where something goes wrong. We're going down to panic F. I must have written something just basic wrong, right? If we go to the tokenizer, case slash, case slash. I mean, I don't see how it would be, right? Am I? We can see that that's the character. Am I not recompiling the program? Like, what is this? I don't understand that part, if I'm being completely honest. I mean, maybe it's something like this, right? Task file. In reality, of course, like this should also have sources, client, right? Basically like this. If it turns out to be that, I'll of course be a little bit peeved, maybe. HP server, let's just say 8080, like this. So it turned out to be that. Again, maybe I should take myself seriously when I say like, oh, I'm very tired or whatever. Yeah. So anyway, now we're parsing some stuff, right? This is of course what we wanted. Let's see here. We have the server here, right? And so what we're doing now is, obviously you can see here, we're receiving some bytes, right? And then we are basically saying, okay, take those bytes and parse a message. This is basically what I've just been saying, that, get and then some resource and then the protocol and headers, that's a message. Let's just call that a message for now, right? So we take that, right? We parse that, and now we can act based on that, right? And of course, it's not very hard to see here that this is effectively what a router is, right? In the end, because that basically allows us to route based on these things, right? And here, do we want to break there? Continue is what we want here now. Sorta. I kind of feel like that's what we want. I mean, we're always closing this connection. Not that it matters. It doesn't matter, of course, right now. We can see here that now we're returning a 404 for our fav icon, right? Which is what we wanted. We're doing this kind of basic routing based on this, right? If the path of this is this, right? Do something, right? And of course, if you were making some kind of framework for this, you would effectively just throw together effectively some kind of thing. You get this message, right? And you could say, parse this as a request, right? So we could say, you know, client parse request here, or more accurately probably HTTP parse request, right? And then with that request, we would then act based on it. This, right? We would have a set of handlers or something that handle requests, right? Some basic step before that might be, before that we do routing, and then you get the request passed to you in a handler, right? So that might be something you would want to do. But yeah, something like this, basically. Anyway, with that, I'm pretty sure there's no one here. But in case there is, I'm gonna end the stream now. And I'll be back soonish with some more videos, probably, on stuff, I suppose. We might actually continue on these lines for some of the HTTP stuff, but I do want to do some with HTTP clients first. That's probably going to be relevant, and so on. So yeah. Anyway, that's that. Have a nice day and ciao.